know. Let me know if you have any trouble seeing or hearing me. Yes.
Like for our sprocket machine project, I didn't get to go. Like, are we going to do a new lesson today?
Today we're going to try to finish the project. So by the end of the
like,
class, this is the
because
last
I
week.
forgot to do like the other stuff that I didn't do. So could I just watch it? Because I can't do it without those parts.
Do you have access to the Google Classroom?
Yes, I do. I just forgot going there.
So open up the Google Classroom, and what I'll do is anyone else missing parts? Speak now, or you will not get the part. But I can upload the file for the part, and then I can show you how you can download a file. And this is good for everyone to see as well, because a lot of the time you will want to download a model that someone else has created. All right, so yeah, Leo, which parts do you need? Or which parts are you missing?
Like, wait, you could still teach, but let me go on shape.
I guess this kind of relies on the assumption that.
No, I think like the squares that you said, I was like no, like after the squares, I just didn't do it. I think. No, actually, I did things after squares.
Here, so if everyone could watch this, this is pretty handy. Let's say that you made a model on Onshape and you're trying to maybe move it onto a 3D printer or something like that. Let me just put it on my desktop. The way that you can transfer computer models between different devices, like for example, between your computer and 3D printer, is usually by saving it as a file, just like any other file that you have on your computer, like a Word document or a text file. There are different 3D model formats that you can use, and Onshape allows you to basically export your 3D models that you make just by right-clicking on them. You can hit export, and it allows you to just save it somewhere onto your computer, as you can do for like most things on your computer. So you can see, like for each of these files, for instance, I'm just exporting them.
If I have a question.
Yeah, go ahead.
If I like get a piece of the it wrong, like the dimensions, can you help me change it?
Sure. Let's see. How about you share your screen while I upload these files to the Google Classroom? Go ahead. Are you saying something? I seem to be muted.
So like basically last time when I tried to edit this, it completely wrecked the entire thing.
All right.
So then I had to keep clicking this undo button. And I'm trying to make it like less thick because it looks really thick right now.
Sure. So go back to your sketch. Yeah, a lot of the times this can happen if you set all of your dimensions and then you suddenly need to change just one of the dimensions. And what can happen is that the new change that you want to make to your dimension is mathematically not allowed. So usually what I like to do is just delete more than one dimension, like delete a couple dimensions that might be affecting it, and then just recreate them. And that'll usually do the trick for me.
Oh, wait. Why does it not work anymore? Oh. But it looks exactly the same as before. Is it actually different? Oh no, wait, never mind. It's different. Oh no, wait, never mind. I figured it out.
All right, great. If you could, okay, I'll screen share again. So back to what I was saying, I just made a post on the Google Classroom with the 4 files that are identical to the ones that I've created so far. Remember, we haven't made the link yet. We'll do that first thing. So if you need a part and you want mine, these are exactly what I just uploaded. So what you can do is click on it on Google Classroom, download it like any other file, save it somewhere where you know where to find it. And then once you save it, the way that you can add a file, so watch closely if you need to do this, Leo, for example. What you can do is import and then go to where you save that file and double click it and it'll bring it in. It might ask you, it might bring up like a dialog box. You can just hit OK and OK for the next dialog box. And then if you wait maybe like 10 seconds, it'll eventually show up in the bottom tab. So when we get to the assembly part, if all else fails, you can always just use my parts that I just posted on the classroom so that you can follow along.
But that's
that part.
cheating.
Sure is, but we're here to learn
Learn,
more so
not
than
Like,
anyway.
like, how do you get it to the like the 3D printer again?
I can talk about that later. For now, I do really want to finish this project because I said we would do it.
And
so
like
we're
another
going
one,
to try to finish this.
another one, like when you said.
All right, so if you haven't already, go down and create a new part. We'll call it link. I did this last time, but if you haven't, just go ahead and create a new part studio as we do using the plus sign at the left here. And the part we're creating is this link between the shaft and the handle, right? The handle is offset radially away from the shaft so that you can actually like apply a torque to the shaft by cranking this handle, as opposed to say like twisting the shaft, which would be really annoying. So that's the part we're going to make. I know in this picture here, it looks really complicated, but we're going to make an extremely simplified version just so that we can finish it in a couple minutes and then move on to the assembly, which I hope to spend most of our time on. So really, like as I always say, like what shapes do you see? I'll kind of cut to the chase here. What I see that's important are these 2 circles, right? One circle where the handle goes on and another circle where the shaft goes on.
So it has to be slightly bigger than the shaft.
Right. If you want this to like slide on over your shaft, you can imagine like you need some extra material around it. Just make sure.
So the way, if you ever squeeze it completely, is 0.2 more good?
I'm not sure I understand the question.
Like my circle, it's 0.2 centimeters. And then if I want to make it so that the link squeezes right onto the shaft, do I have to make it like 2.1 or 2.2?
That's a great question. So a lot of it depends. For the sake of our model, you can make them exactly, or as we say, we call that like nominally, like by name. The nominal dimensions are the same because we want them to exactly fit on top of each other.
So 2.1.
Or if it's 2, you can just make it 2 and then they'll exactly like line up with each other. If you make it 2.1 in the model, you'll get like a tiny gap of like 0.05 centimeters radially. When it comes to real life, though, when you're actually manufacturing things, especially in terms of 3D printing, that is something you really have to think about because as you know, like real life, you don't have exact perfect numbers. Everything is always going to have a little bit of a plus or minus tolerance on it. So
why are we making the link like this?
For the sake of speed, you know, it's all about speed here. Okay, so let's see. I'm just gonna go and take my dimensions. So the end of my handle was 1/2 inch and my shaft was 3/8 of an inch in diameter. So I'm just going to take those numbers.
Wait a minute, my shaft was 2 inches. And my handle is, how big is my handle?
Leo, do you have a question?
In my
Like
hand-
when I came back to the Onshape, I don't have the sprocket, shaft, base, and handle and link. I only have the base.
Make sure that you're working in the same document that you were working in previously.
I
Hopefully,
am.
hopefully throughout the weeks you've been like creating and saving your different part studios in the same document. And if
How do
not,
you save it?
you don't like manually save per se. It's like a online service, so it kind of just it's like Google Docs. It just saves whenever it feels like it. But
Yeah,
Um,
it did, and then when I went back, it just completely went out of there.
I don't really know what to say about that.
Wait, let me see. Is it? Wait, actually.
Does it matter? I have a question.
Yes.
How can you tell? I have 2 questions. First question, how can you tell like the wait, was it? How can you tell the diameter? So wait. Diameter is half the perimeter. So like,
Diameter is 1/pi times the perimeter. But yes.
well, how do I figure out the diameter of the handle?
What I did was, like I said, you can use the measure tool, which is your tape measure at the bottom, or you can just
There's a
click on
measure
it.
tool?
You can click on it, and when it's selected, Onshape will display the relevant parameter, which is by default diameter, I guess.
1.4. And this is.
So all I've done so far is create a rectangle. I created a construction line that just goes through the center. So you can see I was careful to click on the center of this vertical line, and the center of this vertical line so that Onshape automatically creates this midpoint relation, which I kind of need to make sure this line is right down the center.
How do you know
And
how long you're supposed to make your link?
I just kind of guessed something based on how big the circles looked once the circles are dimensioned. So my circles would be 3/8 and half an inch. So based on that, I just picked a number. And as you'll probably see later on, these numbers are all like things we can change once we look at our assembly and decide, oh, I like this, I don't like this, and so on.
Does it matter which circle I make the bigger one and which circle I make the smaller one?
Does not.
Okay, good.
As you can imagine, you just flip it back when you have the 3D object. So I'll just go about making my relations just like we learned so far. So my rectangle is fully black because I dimensioned its height and base. This mid center line is completely black because I made it have endpoints that are right on the midpoint of these vertical lines. These circles, I've now made them coincident to the center line, this construction line that I created. And now all I have to do, these circles are already dimensioned, so I just need to make their location dimensioned. And again, I can just pick a random number. Maybe something like that. And something like that. And with that, this is like the bare minimum that you can.
Wait, how did you get the mid-center point construction line?
Using the construction tool, you have to first click the line and then use the tool, and that'll just toggle between solid line and construction line.
How did you make it so that there's a center construction line?
So to get this line, I just drew the line as I would any other line using the line tool. And I was careful to click on this little square here, which automatically creates your midpoint relation. And again, on the other side, to automatically create that midpoint relation, I click on that little square, and then I
I
have
don't
this
have
line.
the square on the other side.
You have to be pretty careful about it. And if it doesn't show up, you can always manually create those relations using what we know about like creating relations. So I would just do like the midpoint relation, click this point, click this line, and it would work.
Like, how do you make it black again?
Okay, I made the center point line, but I don't have the center. Oh. How do you make it so that like circles are on the line?
That's your coincident relation. So you
The circle and
use
click
the
the
coincident
line.
tool, you hit the center of the circle, the center point of the circle, and the line, and that'll bring them so that the center point of the circle stays on the line.
Let's- My circles are not black.
So make sure their size is dimensioned, make sure their position is fully defined. You'll probably need a dimension to do that. And make sure they're fully related to the construction line, which itself should be black because it's fully related to this rectangle.
Like when I do the dimension for 2 and 0.75, it makes it so small. And when I do 0.75, like it just, the construction line just goes on top of the, like the above line.
What you should probably do, yeah, Onshape is a bit annoying in that it rescales your view whenever you create a dimension that's like bigger or smaller than what it thought it was. So what I would do there, honestly, it's probably faster to just like delete it and like delete those lines and just recreate them. Like just make
And
a new
do I
rectangle.
still need a dimension if it does it again?
You should dimension it because that's the only way that we know that our parts will or will not fit together.
Oh. But how about if it does it again?
Once you create like one dimension, Onshape like kind of sets its like viewing scale, right? Like before you have anything, you don't know like if you're like really zoomed out or really zoomed in because there's no reference. But once you create that first dimension line,
Compared to yours, it's like small. So it's okay. But is this like when the 0.75 is the problem?
Next, Druid.
right? Yeah, when you have this, extrude it to whatever reasonable thickness, maybe like an 1/8 inch or a 1/4 inch. If you're having trouble with the sketch, I would say like start with a rectangle, like start with just the rectangle, dimension the rectangle, and then Onshape will grab its like size scale, right? And you just zoom to whatever is appropriate. And then from there, create the center line and create the circles. And that should work out for you. I'm going to move forward because I really do want to get you through the assembly as well. So I'm just going to extrude it to whatever depth and call that done. What we're going to find out later on, I guess I'll say this now. You'll notice the handle is a bit like, it's a conical surface here. So it's not like perfectly going to fit inside of this link, right? The link is a cylindrical hole. So it's like we're trying to shove a cylinder into or a cone into a cylinder, but don't worry about it. If you are really, if you care about it, you can always go back to the handle and like make a cylindrical part here to fit with it.
Oh no.
All right, so if you've all got the link, that's great. These are all the parts to our sprocket machine. If you want to, you can improve the appearance of your link by changing the sketch. I'm sure you all have some idea of how to do that. You can also like add fillets. So if you want to round off these corners, for example, this is pretty optional, but it will make it look slightly.
How do you round off the corners?
Just slightly nicer. That's using our fillet tool, which we have used before
Yeah, fill.
to make like a sphere, for example. But that's really optional. That's just a cosmetic or
I want to do it.
Oh,
weight saving type of thing.
Where is it?
Your fillet tool is going to be in like the second group of 3D tools. Leo, do you have a question?
like, could you do it back because the circle dimension? I'm still not done with it.
No.
Okay.
Why does it not look? I can't figure it out.
Depth is really up to you for the question in chat. I think I made it an 1/8 inch, so 0.125.
I did 0.5.
All right, so if we're all good on this, we're going to start the assembly now. And it's going to be really tight to fit this all in, but hopefully if we all move efficiently and hopefully we remember that one time where we stacked 2 blocks on top of each other and use that experience to kind of bolster your way through this. All right, so we go to the assembly tab. By default, you already have an assembly tab. If not, you can always create one the same way you create a part studio using the create assembly button there.
Why does it not fill it on both sides?
You need to select every edge that you want to fill it unless you select a face, in which case it will automatically select every edge that is it like a boundary.
You can select a face?
I'm not sure if it does this in Onshape, but in a lot of other CAD programs, if you select a face,
What
it'll
is
just
this?
automatically pick all the edges. But I say don't worry about the link right now. If you want to do that, you can do that later. We're going to go into assembly and we're going to insert our parts. So we're going to quickly take a look back at the slide and do a quick inventory. So we're going to have 2 handles. We're going to have 2 links, 1 shaft, 1 sprocket, 1 base. So the only thing that we have 2 of is the link and the handle. So we hit insert as we've done once to do the 2 blocks on top of each other. And we're going to put in 1 base. And you click it here in the drop down, and then you click once in your workspace, and then once it's not selected, once it's not highlighted, that's when it's like in there.
1 sprocket.
Yeah, you want 1 sprocket.
1 shaft. How many links?
You need 2 links
How many
and
shafts?
2 handles, 1 shaft.
2 links and 2 handles?
Indeed.
2 links. Bro, my.
And once you click all of those in, you hit the check mark to tell Onshape, yes, this is what I want.
There's so many.
All right, now for the speed run, we're gonna put all these things together.
In
So-
30 minutes?
Indeed. So remember what I was saying, like when you first put things in, they're just free. It's like you dumped it all onto a table, like they can all move wherever they want. They have 6 degrees of freedom. They can move up and down, left and right, forward and backwards. They can spin about X, Y, and Z. So they can like roll, pitch, and yaw, all of that. Like basically there's no rules at all about how these parts can move. And the point of assembly, the point of these mates that we're going to apply is that we're going to take away those degrees of freedom so that there's only a specific way that these parts can move and be located with respect to each other. And so the very first thing I'm going to do is I'm going to pick 1 part and I'm going to basically fix it with respect to the origin of the assembly. Remember, the only thing that you have when you first make an assembly is its origin. That's the center of the assembly. And for various reasons, it's a good idea to make sure that your parts are sensibly located with respect to that origin. So to do that, we're going to use the fasten mate. Remember, this is the most basic one. It takes away all the degrees of freedom. It's like glue, right? You can't move, you can't rotate. All you can do is
You can still
keep
do
position.
stuff after glue.
It's like a mathematical glue, an idealized Platonic glue. And so, yeah, as you recall, maybe that was a bit fast with no explanation, you click on the mate, and mates rely on what we call mate connectors. And the way that you get mate connectors is you just hover over the part roughly where you want the mate connector to appear. The mate connector is indicated by that little symbol you see by my mouse, that little circle with the 3 lines coming out of it, like the Pac-Man face in it. So I'm going to click just somewhere on the bottom of my base. This part isn't really critical, and somewhere on my origin. And once I click on those two, Onshape like snaps them into position. And if I like that, if I'm okay with that, I can hit the green check mark. And if for some reason it comes in like upside down or something, I can hit the big arrow. If it comes in like rotated 90 degrees from what I want, I can hit the like circular arrow to rotate it. But once I'm good with it, I can hit the check mark.
I don't know what way is correct.
Really, there is no correct way. It's kind of like picking which plane you want to make your
Can you
first sketch
change
on.
it after?
Yes, you can. Like anything else, you can edit a mate, and that'll bring back up the dialog, and you can change
You can't move
whatever
it.
you need to change,
Yeah.
right? But now we can no longer move the base. It's fixed in place. Now it has no degrees of freedom, right? It can't rotate anymore. It can't move. So we're golden. Next thing, we're going to, I think we're going to put this shaft into the base. And so let's think quickly about what a shaft can do when it's mounted in the base, right? We have our sprocket machine. We want to crank the handle so the sprocket can spin. So what kind of degrees of freedom of motion should the shaft have?
Mm,
Should be able to move left and right,
no.
right? Should be able to move like up and down or forward and backwards.
Well, which way is the shaft again?
Let's see. If we're going like this, like, do we want the shaft to be able to move like here or like this?
Wait, I want my shaft. I want my sprocket to be the same size as my shaft, like the center circle.
You do want the center bore to be the same size, but as long as you have a center bore in your sprocket, don't worry about it. Like the assembly will still work. It'll just look like there's an air gap, and you can fix that later on your own time. And so to kind of answer my own question there, we do not want the shaft to have any translational degrees of freedom. We don't want it to be able to slide in and out like left and right this way, left and right. We don't want it to be able to move like up and down or forward and backwards in like the radial directions. And in real life, that would be like this like a bearing surface that prevents your shaft from like escaping the base, right?
Aren't we supposed to put the sprocket in before the, oh no, wait, never mind.
So assembly, like, you're not really constrained by the realities of physical matter. When you're working in here, things can go through each other with no problem. So that's not a problem here, but if you're designing something that needs to be assembled in real life, that's definitely something to think about. Anyway, I forget if I introduced any mates other than fasten. So I'm gonna reintroduce maybe, or introduce for the first time, the revolute mate. And you can see that this allows for exactly 1 degree of freedom. It's like you have a shaft and a bearing, for lack of a better example. It can only rotate about 1 axis. It can't do any of this. It can't do any of this kind of rotation. It just rotates along its axis, and it can't move translationally in any direction. That's exactly what we want. We're going to select the revolute mate, and it brings up a dialog box like this one. And again, we need to give it some mate connectors. So here, I want my mate connector to be the center of my shaft. And thankfully, Onshape is smart, and it recognizes that the center is probably going to be a pretty common mate connector that people would want. So it allows you to hover your mouse over the center here and create that mate connector. Now the question is whether Onshape will allow me to create a mate connector here between these. And it seems like it will not. So I'm going to take a step back here for a second. What you can do in cases like these where Onshape doesn't automatically like guess where you want your mate connector to be, you can either like manually create an offset. So you can type in a number that tells Onshape like how far in or out away from each other the mate connector should be placed. Or you can just manually create a mate connector. And that's what I'm going to show you. So this second tool here, right after insert, but before these mates that we learned about, we have a mate connector thing here. And so if you click on that, it allows you to create a mate connector. It's basically like creating anything else that we've created so far. And if I create the mate connector, I guess it's been a while since I used these. So it allows you to select a geometry, for example, let's see, the circle.
I clicked it already.
And okay, it's coming back to me. Between entities is probably what you want. Well, let me just see if this works the way I think it does. All right, well, the exact way these whole mate connector things is perhaps escaping me for the moment, but don't worry. Take a quick moment to figure out what the distance is between your base. We're just gonna manually create the offset, and you can worry about the mate
Distance
connectors.
between where and where?
So if you just click on this part of your base, the distance between the insides of each of these like standing up parts. So in my case, I can see that this is 1.1 inches.
Wait a minute. So do you click like the edge of it?
Yep, I just click that edge, and Onshape will tell me. You can also use the measure tool explicitly. Just click on the tape measure, and you can click on the line.
Like each of the sides?
We're just interested in this one dimension, like the distance between this face and this face. And you can also click that, and it'll tell you it's 1.1 inches apart. In my case, at least. So keeping that number in mind, what I'm going to do is just create.
Parallel distance is 6.4.
Yeah, that's what you want. So yours would be 6.4 centimeters, I'm guessing.
Okay.
So now what I'm going to do, instead of the whole mate connector thing, I'll just go back to my Revolute mate.
Revolute?
Yep, the second one, the one after fasten.
Yeah.
I'll create my first mate connector at the center of this shaft, and I can just like hover over the center and it'll create it. And my second mate connector, I'll just place right here on the inner face of one of these like flanges. Right there.
Bam. Bruh.
And you can see it's not centered. And what we're going to do is we're just going to create an offset. So if you click on the offset check mark here, you can see this new thing comes up. And here I'm just going to type in that number that I kept in my mind, 1.1 divided by 2. And hopefully it goes in the right direction.
Divided by 2. Okay.
Because I want to make up half the distance that it would take between it. And mine went the wrong way, so I'll just put a negative sign there.
Mine's a little short.
You can just put like the negative sign there and it'll offset in the corresponding direction. And at this point, if you are realizing that your parts are too short, for example, this is when you can quickly go back and like give it another inch or two. And the assembly you'll find will update accordingly. But what we have now with that Revolute created is we can just rotate the shaft. So you really can't tell because the shaft is axisymmetric, but if you click and drag it, it is allegedly spinning in there. All right. If there are no questions about that.
Let me add one of these. Let me get rid of this. And then Revolute the center of this and the center of that. And that. Wait a minute. Why does it look exactly the same?
If your part's not updating from like when you edit a part, usually when you go to the assembly tab, it just updates. You might want to perhaps like hit that refresh looking button. I'm not quite sure off the top of my head if that does like update
Also,
your
it's not
parts.
working anymore. Oh, I forgot I changed it. Whoops.
All right.
Wait, yeah, it's not working anymore.
What is not working?
The Revolut.
And that the mate is like broken. There's a warning sign or something.
No,
All right.
just I typed in my 6.4 divided by 2, which is 6.4 divided by 2. What the?
All right. Well, so as we go into the next thing, let's think about what kind of mate that we want between our sprocket and our shaft, right? So the idea is we crank this handle and the sprocket spins. And so between the shaft and the sprocket, relative to the shaft, that means the sprocket cannot move, because when we crank the handle, the only thing we're affecting is the shaft. We're rotating the shaft, and rotating the shaft is supposed to cause the sprocket to move. So in this model here, you can see there's like a little rectangular cutout in the sprocket, and that's what we call like a keyway. And like in most like real machines, you often use what's called a key, something like that. You have a little rectangular bar that goes in the shaft, and that just locks your components, something like this. It locks your components together rotationally so that the shaft can transfer rotation, it can transfer torque to whatever it's attached to, which in this case is the sprocket. We don't have any of that, don't worry about it. We're just going to use the power of this fasten mate, which takes away all its degrees of freedom. And so relative to the shaft, the sprocket has no freedom. So we're going to use another fasten mate between the sprocket and the shaft. So here you kind of have to be a bit clever. It's really an exercise in like messing with your mouse and like your view position to get the right mate connector. But if you do it right, you can see Onshape like offering these 3 points. And one of them is like right in the middle. So that's the one I'm going to click on.
One that covers the entire thing.
You can see like right where my mouse is right now, and you can see where my mate connector is. Little
Or the
Pac-Man
one
in
that's
the middle.
like
So I want
the one
my,
that's in like the very center of the shape.
right, that one.
Like
And
that covers the entire area of it, of the center.
I'm not sure what you mean by covering the entire
Like
area of the center.
it circles the entire circle. Wait, I think I got it.
All right,
Yeah, I got
well,
it.
that's the important thing. So you fasten sprocket to the shaft, and like even if it's not like perfect, maybe you missed the mate connector and you got one that's like on the edge of it. It's just not going to be like centered, but you can fix that.
It's completely centered.
So get my check mark. And now what we can observe is if we click and drag the sprocket, it now has one rotational degree of freedom, even though I fastened it, because the fasten only took away all the degrees of freedom between my shaft and my sprocket, right? So even if you couldn't tell before, my shaft is spinning right now along with the sprocket. From the shaft's point of view, the sprocket is not moving, right? If you're standing on the shaft and you're like spinning around with it, the sprocket would not be moving. So that's kind of what we achieved right there. Now we just have the handles and the links to attach. So I guess we'll start by attaching these links. Actually, let's do the links to the handles first. So again, when we have our handle and our link, if we think about this assembly, maybe in a really nice machine, like the handles would rotate with respect to the link so that you can just like keep a firm grip on it and you can like crank it. But let's say ours is not quite that nice and you kind of, the handle is constantly slipping in your hand as you crank on it, right? So we're going to fasten the handle to the link so that they can't move against each other, so that they're glued together, as we say. So again, we're going to use a fasten mate. And here, if you're very observant, you'll note that the handle kind of intersects the geometry of the link. They're going to have like volumes that are occupying the same space. And that is a bit of an oversight on my part, but it won't affect anything. And if anything, it's a good reminder that CAD is not real life. So I'll go in and I'll just click on the circle as my make connector. So this
The
back
entire
circle, right? This back circle of my handle and just like one of the edge circles. So not the center circle, but like the edge circle of the 3
edge?
dots here.
Okay.
When you see the 3 dots, when you hover here, you want the one on the edge. Whoops.
And then I click the end of my thing.
All right, so do that again for both of your.
Wait, am I supposed to
handles.
attach them to the shaft or to attach them to the handle?
You're trying to get your links to the handles
Oh, whoops.
right now.
Whoopsie daisies.
Again, just do this again. Whoops.
What?
Yeah, it's a lot of zooming in, rearranging your view, trying to get to the thing you want. And I'll just have it so that like the thick part comes out through the link as opposed to this way, which
I did it.
is a bit odd.
But how do you? But it just fits in completely.
Not sure exactly what you mean by
Okay,
that, but
can I connect it now?
so
I
right now we've connected our links to our handles, right?
Yeah, can I connect it to the shaft?
Great. So now let's take one last moment to think about our motion here. With respect to the shaft, how does the link move, or how much freedom does the link have?
It needs revolute.
So if you did a revolute, what would happen?
It would
The
go
link
crazy.
would be able to freely rotate about the shaft. So that means if the shaft were fixed to be perfectly still, I would still be able to crank the handle. And that also means that I can't use the handle to force the shaft to move, because the shaft is allowed to like be perfectly still while I move the handle around, right?
So it's fastening me.
Right, this is another fasten mate, and you can think of it again like a sprocket or that kind of interface. We're trying to transfer this revolution between the components. We're trying to transfer rotation, we're trying to transfer torque. So in those cases, you usually want some way to lock them together so that they can't slip and rotate against each other.
What the? For some reason, when I fasten the thing onto I fastened the link with the handle on it to the shaft, only the link moves.
All right, so that's a point that I'm going to explain now. So I take my first make connector, I take my second make connector. Those are just the respective circles. And you can see that Onshape only updates one of them. And so this is kind of when Onshape immediately like snaps your part to its correct location, it's kind of just giving you a preview, right? Onshape hasn't actually moved your components yet. It's just telling you that if you were to create this mate, if you were to click that green check mark, this is where that part would go, but it hasn't actually moved it yet. So it hasn't actually looked at every single other mate in your assembly and like recalculated where all your other parts would be updated to if you were to create this mate. It's just giving you like a light version of the preview.
So I
If you want-
redo it.
If you want the full version of the preview, you can just hit solve the full assembly, and then Onshape will go through all your other
Right.
mates, and then it'll figure out where all the other parts should be snapped to actually be like correct. So I snap it, I hit solve, and now my handle also snaps to its correct location. And here I can see that this is kind of wrong. I don't want my handle to go back in through
Yeah.
the machine. And so if this happens to you, what you can do is
It works.
flip the primary axis using the big arrow. And if you do that, it just does that. You can see the handle didn't update, but again, whenever you do something like that, you have to hit solve again, and Onshape will recalculate the new positions of where it's supposed to be. So if you're good with that, you hit the check mark, and now you can really start to see things happen. We only have one handle on so far, but if you grab this, what I'm now realizing is a comically large handle,
Right.
you can you can grab that and rotate it. And you can hopefully see through the zoom lag. I'm able to spin the sprocket using the handle.
Bruh. I did it 5 times and it didn't get it right once.
All right, and last thing we do is another fasten mate for the other handle. And it's exactly the same as what we just did. So I'll select the circle here. And I'll select the circle here.
Let's go. I'm done.
I'll make them together, hit solve to see what it does. It looks good to me, and I'll hit the green check mark. And now
it's lagging.
is your Onshape is lagging, or am I lagging? The screen share is lagging.
Never mind, I got it. It's working.
Great.
I just feel like the sprocket is so small.
Yeah. I think in my case, I made the handle way too big and it looks a bit silly.
Same.
But what you can always
works.
do is
but it works. Let's go.
Hopefully you have the requisite knowledge to go back and like change the dimensions of these. Even though it's a bit of a pain, you can change it. And one like warning I'll give you is that whenever you change a part that's part of an assembly, when you update the assembly, there's a good chance that Onshape will forget about, or it'll not be able to figure out which part of the geometry is supposed to have the mate connector, right? Like if you change a circle and you move it to a different position, Onshape might not be able to figure out that that new circle in that new position is where you want the mate connector to go. So in a lot of cases, when you update a part, you have to update the mate again. And you can just do that by editing the mate and like just re-scoping those to the correct geometry. So now that we're here, we're basically done. I'll take questions in a few minutes if you're still trying to reach this point. But I do want to show you a couple neat things you can do from here. The first of which is if you right-click a mate, for example, the Revolute mate, you can click Animate. And so you select the mate and it will basically sweep through every position that mate allows. So for Revolute, you can like spin around 360 degrees. So I'll just say 0 to 360 degrees. Steps is like how smooth the animation should be, like how fast the animation should be. And then playback type, reciprocate will do back and forth. Single will just do it once. Loop will do it forever continuously. That's what I want. And then if you hit play, you can see hopefully a smooth animation of your sprocket machine spinning, or my sprocket machine spinning.
Mine's spinning too. Yours is lagging.
It's unfortunate, but such is the internet.
I'm gonna make mine way faster. Bruh.
A bigger number makes it slower, by the way, I believe.
You can't make it faster.
You can reduce the number of steps, and I think then it'll go super fast.
I did it. Oh my God. Oh.
And I guess a few other things that are kind of neat that you can do. If you go to each of your studio parts, if you right click the part in like this bottom tree here, you can hit edit appearance. And then you can change the color of your parts. So if you're feeling festive, you can edit the appearance of each of your parts, give it a different color. And when you go back to your assembly, you'll see that the new appearance propagates to the assembly. So that's just a fun thing to do. Other things you could do from here, like you can spend more time, put some more love and care into the geometry of like the links or the handle or things like that. You can adjust their sizes and whatnot. You make the machine more complicated, things like that. It's really up to you at this
It looks
point.
like it's from. It looks like it. It looks like Pinocchio.
Yeah, it's a bit of a clown machine now, but
Yours is lagging like really badly.
too bad. Unfortunate.
I'm done too.
All right. So anyway, what I'll say here now as we approach the end of week 8, which is our last class together. So things we didn't get to that I think are useful are more of the advanced types of mates. So a lot of these you can figure out just by looking them up. Onshape has like a documentation. So if there's ever a feature in Onshape that you don't know how to use, you can just go to the
Bruh.
not Onshape documents, but
I don't know how to change the color. It's not working.
but if you go to the Onshape website, like they'll be able to explain anything to you. So you really have the resources to learn whatever you need to learn about, at the very least, Onshape, and usually about most other different CAD programs. And so in terms of other, like where you can go from here, a lot of you, I assume, are students. So what I'd suggest is like maybe look into if your school has computer lab or like a technology class or something of the sort, see if like what kind of CAD programs that are available to you as a student, because as long as you are a student, you'll usually get a lot of CAD packages that aren't free. You'll be able to use them for free as a student. Just like for Onshape, you made like that education account because you're a student. A lot of schools will like pay for their students to be able to use these different things. So a lot of the common ones, you have like Autodesk Inventor, different Autodesk products. I think Tinkercad is one that's fairly well known. That's
I already
that's
have
free,
Tinkercad.
right? So you might already know about that one. Other ones that are pretty like commonly used, you have SolidWorks.
You have Brilliant.
Sure. Another common one that's used in like the aerospace industry is called NX. So maybe that was not the greatest search. Siemens NX is another CAD program. At the very professional level, we have something like Creo or maybe a CATIA, which is made by the same people at SolidWorks, I believe. Yeah, Dassault Systems. So there's a lot of different things out there, but what you'll figure out is that a lot of the basic tools that you've learned so far, a lot of the same ideas of going from a sketch to using like extrude and revolve and similar tools to get your geometry, and then putting those together, defining a bunch of rules about how they can move into an assembly. Those principles are all going to be the same no matter which CAD program you use. Unless it's a really weird CAD program, like some kind of direct modeling type of thing, in which case it might be completely different. But for most parametric CAD software that you use for engineering and that type of thing, it's going to be a lot of the same skills that you've learned here. So this does carry over even if you don't end up using Onshape for any actual work. Like I don't use Onshape for anything myself, but I still am able to teach this class because I use other CAD programs a lot that are pretty similar. And other things like if you're really interested in CAD, if you really want to improve at CAD, all I can really recommend is just to get a lot of practice, because the more time you spend trying to make things, asking yourself the question like, what shapes do I see? How can I turn this pretty complicated real life object into a lot simpler shapes that I know how to make using my basic sketch tools? Just going through that thought process a lot will really solidify that process and make you a lot faster, a lot more efficient, a lot more accurate at making models. And yeah, like when I was first learning how to CAD, the way that I really pushed myself was I would just pick random objects around me and try to model them in my CAD program. Like the lamp on your desk or your computer mouse that you're using right now. Like anything goes. Chances are those products were already designed by some engineer using a CAD package. So you know it's possible. And other than that, that's all I really have to say for y'all. Hopefully you enjoyed learning. Hopefully you did learn something about CAD, and hopefully that you continue to want to learn and improve at doing CAD modeling. So with that, I'll stick around for the last few minutes to take any questions if you have any problems with the assembly. Hopefully this recording, you'll have access to that if you want to slowly go back and watch all the assembly stuff. But yeah, good session.
Okay, thank you, Eugene. Sorry for jumping in. So I just want to let all our students know that we will have a level 2 CAD class. If you are interested, so you will still have the opportunity to continue the class with Eugene. And also there is a STEM center at AOE. So I will put the address in the STEM center. So for students who would like to, for example, print out the 3D printing object, you are more than welcome to visit us at this address. I will just put it here. So we will meet our, robotics team as well. So you will see how the 3D printer working. So you're more than welcome to stop by. Thank you so much, and I wish you have a very good session, and I look forward to see you next week or next session. Sorry.
Hi, Karen, I have a quick question. So going to the center for printing, is that any day, any time, or is it any specific office hour?
We have Saturdays and, Fridays we're open. So just let us know ahead of time. We'll try to accommodate your schedule. Usually we are open from 10 to, from 10 in the on Saturday. Usually we stay open until like evening time, because our FTC teams, they will prepare for their championship events. So we are still open this week and the next week. And Sunday we're open from 1:30 in the afternoon. Yeah.
Okay, thank you.
Sure, thank you.